Welcome to Lesson 7 of Business Intelligence and Management Support Systems. In this lesson, we will turn our attention to two closely related topics. They are data visualization and dashboard design. These are the most visible outputs of any business intelligence system. They are the point at which all the data that we have previously collected, cleaned, and modeled finally becomes meaningful to a decision maker. So by the end of this lesson, you will know how to choose the right chart for a given situation, and you will also understand the principles behind designing dashboards that are clear, effective, and professional. These are the learning outcomes of this lesson. So what exactly is data visualization? Now let's consider the most fundamental level. Data or information visualization is the use of visual representations to explore, make sense of, and communicate data. Now you can notice that the definition contains three distinct purposes. The first is to explore. In the early stages of an analysis, visualizations help us discover patterns, outliers, and relationships that would be invisible in a raw table of numbers. Then the second, that is to make sense. Once we have data, visualizations help us to summarize, aggregate, and contextualize it. And the third purpose is to communicate, to convey insight clearly to other people who need to make decisions. There is also an important conceptual distinction to appreciate here. What a visualization portrays is not the data itself, but rather the information derived from it. In other words, a good chart presents aggregations, summaries, and contextualized comparisons, not raw records. Think of it this way. A spreadsheet with 10,000 rows of sales transactions is data. A chart showing monthly revenue compared against last year is information. And that distinction drives every decision we make when designing a visualization. Before we can select a chart, we need to understand what type of data we are working with. There are three categories that matter most in data visualization. The first is nominal data. Nominal data can be counted, but it cannot be ordered or aggregated in a meaningful way. For example, take product categories such as books, movies, and music, or gender, or geographic regions like Western, Southern, and Central provinces. If I told you that category A came before category B, that statement would be meaningless. There is no inherent sequence. The second category is ordinal data. Ordinal data can be counted and ordered, but it cannot be aggregated mathematically. Dates, academic grades, ranked preferences such as like, neutral, dislike, they are all ordinal. We know that an A grade is better than a B grade, but we cannot say that an A is 2 times better than a C. The third category is metric data. Metric data, also we call it quantitative data, that can be counted, ordered, and aggregated. Revenue, profit, temperature, and the number of customers are all metric. We can add them, average them, and compute ratios from them. There is also a fourth consideration. Some data, such as age or a test score, can function as either ordinal or metric, depending on how you intend to use it. If you are grouping people by age bracket, it is ordinal. If you are computing an average age, it is metric. Context determines classification. Now we come to one of the most important topics. How do you select the right chart? The decision is not arbitrary. It follows directly from two things: the type of data you have and the analytical question you are trying to answer. Now, for comparative analysis, that is, you are comparing the magnitude of values across categories. This is where you are working with a nominal attribute and a metric. So the bar chart is the most effective choice in this case. It should be sorted from largest to smallest so the reader can immediately see the ranking. For contribution analysis that shows how individual parts make up a whole, a pie chart works well, and when you have few categories, typically 5 or fewer. When there are many categories, a heat map or tree map is more readable. For time series analysis, tracking how a metric changes over time, a column chart works well when you have a small number of time periods. But when you have a large number of time periods, a line chart becomes more preferable. For correlation analysis, examining the relationship between two numeric variables, a scatter plot is the appropriate choice. When you want to encode a third variable, you can extend this to a bubble chart, where the size of each bubble represents the third dimension. Finally, for relationship or network analysis between two nominal entities, such as which airports have flight connections, a network diagram is the appropriate choice. Now, think of chart selection the way an engineer selects a tool. So, a screwdriver and a hammer are both useful, right? But using the wrong one for the job creates problems. A pie chart with 12 slices is like using a screwdriver handled as a hammer. It might seem to work, but the result is poor. Beyond the basic chart types, there is a family of composite and advanced visualizations that are particularly valuable in dashboard design. Let's go through each one. The heat map uses color intensity to encode a third variable across a two-dimensional grid of categories. So you can see there's a heat map of support ticket volume by day of week and hour of day. So you can see which time slots are busiest. This information would take considerable effort to extract from just a data table. The bullet graph is a compact, information-dense alternative to the gauge or speedometer chart. It shows the actual value, a target or a benchmark, and qualitative performance zones, all within a single horizontal bar. Bullet graphs are particularly valuable on dashboards because they convey the KPI performance in far less space than a gauge. Spark lines are miniature trend lines, typically embedded within a table row. They do not have axes or labels. Their purpose is just to show the shape and direction of a trend. You can see the example here. There are 5 metrics, each accompanied by 7-week trend line. It is occupying almost no additional space. The bubble chart extends the scatter plot, as mentioned in the previous slide, by using bubble size to encode a third variable. So here, Revenue size on top of the two axis dimension is the bubble size. This allows you to visualize three dimensions of data simultaneously. Finally, the graph matrix. It repeats the same chart type across multiple categories in a grid layout. Here you can see regional sales trends arranged in a 2 by 3 grid. The reader's eye can compare across panels without needing to relearn a new chart structure for each one. Color is one of the most powerful and most frequently misused tools in data visualization. Used well, color guides the reader's eye and encodes additional information. If used poorly, it creates confusion, distortion, or simply visual noise. There are three functional categories of color in visualization. The first is categorical color. Distinct hues are used here to separate different groups or categories. The key rule here is to use no more than 7 distinct colors, because beyond 7, the human eye struggles to reliably distinguish between them. And if you use more than 7, the chart will become harder to read even more than a table would be. The second is sequential order. Here, a single hue varies in lightness or saturation to represent an ordered range of values, typically from low to high. You will see this frequently on heat maps. The third is diverging color. This uses two contrasting hues meeting at a neutral midpoint. This is appropriate when your data has a meaningful center. For example, when visualizing values that are above and below a target or average. The golden rules on the right here, you can see, are worth committing to memory. Use color purposefully, never decoratively. Ensure that your palette is accessible to color-blind viewers. Approximately 8% of people have some form of color vision deficiency. So never rely solely on red-green distinction. And maintain consistency. If blue means one product category on one chart, it must mean the same thing on every chart throughout your report. Now you know how to select the right chart and the right color. Beyond that, effective data visualization requires a narrative structure. This is what we mean by storytelling with data. The idea that a visualization should not merely present numbers, but guide the viewer toward a conclusion. The framework presented here has 5 stages. The first is to set context. So before showing any data, you must first establish who the audience is and what decision they are being asked to make. A chart designed for a chief financial officer looks very different from one designed for a warehouse supervisor. The second stage is show the data using the chart type more suited to the question. The third stage is to highlight the insight. This is where the color, annotation, and reference lines become critical. Don't rely on the reader to find the key point. Draw their attention to it explicitly. The fourth stage is to provide the context. Raw numbers are rarely meaningful in isolation. A revenue figure of $4 million means nothing without knowing whether it exceeds last year's figure, whether it meets the target, or how it compares to competitors. Context is what converts a number into a decision-relevant insight. The fifth and final stage is a call to action. Make explicit what the viewer should do with this information. A visualization that inspires no action has failed its purpose. Three additional principles underpin all of this. First, one core message per visual. Do not crowd multiple questions into a single chart. Second, pre-attentive attributes such as color, size, and position direct the reader's eye before conscious thoughts even begins. Use them deliberately. Third, your chart title should state the insight, not just label the axis. Revenue declined 12% in quarter 3. This title is far more useful than a title such as quarterly revenue. Let's move from individual visualizations to dashboards now. A business dashboard consolidates dozens of frequently used reports into a single, easy to understand application. This enables at a glance monitoring of performance. There are three defining characteristics that differentiate a dashboard from simply placing multiple charts on a page. First, consolidation. A dashboard brings together data from multiple source systems. So the decision maker does not have to open 5 different reports to get the full picture. Second, timeliness. A dashboard presents dynamic current data, not a static snapshot produced once a week. Third, drill down capability. A well-designed dashboard allows the user to click from a high-level summary into the underlying detail. So they can move from what is happening to why it happening within the same application. In Power BI, a single report page presents one dashboard view. A report with multiple pages functions as what is sometimes called a dashboard book, a tabbed collection of related views serving different analytical purposes. Dashboards are not all the same. We classify them along 3 dimensions: scope, business role, and time horizon. In terms of scope, a dashboard can be broad. It can cover the entire organization, or specific, which focuses on a particular function, a department, product, or process. In terms of business role, a strategic dashboard provides a high-level, long-term view of organizational performance and is typically consumed by senior leadership. A tactical dashboard measures progress against specific strategic initiatives and is used by middle management. An operational dashboard focuses on near-term day-to-day process performance and is most useful to frontline supervisors and operational staff. In terms of time horizon, a historical dashboard looks backwards to track trends over time. A snapshot dashboard shows performance at a single point in time. A real-time dashboard monitors live activity as it happens. This is typical in contact centers or manufacturing environments. And a predictive dashboard uses historical patterns and models to forecast future performance. When designing a dashboard, your first question should always be, who is the primary user? What role do they play? And what time horizon matters most to them? The answer determines which type of dashboard is appropriate. Now, for example, take a hospital. A hospital CEO uses a strategic dashboard showing patient outcome rates and financial performance over years. A department head will use a tactical dashboard tracking monthly bed occupancy versus targets. A ward sister might use an operational dashboard showing real-time patient waiting times and staff assignments. Regardless of the type, All effective performance dashboards share a set of common characteristics. First of all, at a glance readability. The dashboard must communicate critical information within seconds of opening, without the user needing to read large blocks of text or perform their own calculations. This usually means using KPI cards, color-coded indicators, and clear visual hierarchy. Second, a unified view. The dashboard combines data from multiple source systems into one coherent interface. The user should not need to cross-reference external reports. Timely data. The dashboard must present data that is sufficiently current to be actionable. A dashboard showing last month's sales figures is less useful to a sales manager than one showing this week's sales figure. Drill down capability. The user should be able to navigate from high-level summary to the detail that explains it. In Power BI, this is achieved through drill-through pages, tooltips, and hierarchical visuals. Minimal training requirement. A well-designed dashboard should be largely self-explanatory. If extensive training is required just to read it, the design has failed. And finally, low maintenance. A dashboard should require minimal ongoing coding or manual effort to keep current. Automation is key. One of the most important and frequently underestimated aspects of dashboard design is metric selection. A dashboard populated with the wrong metrics, even if it is beautifully designed, will fail to support good decisions. What makes a metric perfect? There are 4 criteria. First, number 1, it must be actionable. There must be a specific, repeatable action that a user can take in response to a change in that metric. If a metric goes up or down and no one knows what to do about it, it should not be on the dashboard. Second, it must be transparent. The calculation must be simple enough that users can understand and trust it. Third, it must be accessible. The underlying data must be reliably available. And fourth, it must be recognizable. Everyone who sees it must share the same understanding of what it means. Beyond those 4 qualities, metrics must also support meaningful comparison. Time comparison allows you to assess whether performance is improving or declining. Cross comparison allows you to see whether one region, product, or team is outperforming another. And goal comparison allows you to assess progress against a predetermined target. In Power BI, DAX measures, written using functions such as calculate and divide, are the primary mechanism for building these comparison metrics. Even if every individual visualization on a dashboard is well designed, the dashboard as a whole can still fail if the layout is poor. Information cannot be placed just anywhere on the dashboard. Nor can sections be sized simply to fill available space. The diagram here illustrates a concept from visual design called optical areas. When a person first looks at a screen, their eye naturally moves to the top left corner first. This is the primary optical area, and it has the highest visual weight. The top right is the strong fallow area, which receives attention second. The bottom left is the weak fallow area, and the bottom right is the terminal area, which receives attention last. The practical implication is clear. Your most important KPIs and primary visualizations should always occupy the top left of your dashboard. Supporting charts and contexts belong at the right and bottom. Detailed tables, if needed, belong at the bottom. The hierarchy to follow is navigator at the top. This includes filter, data selectors, and breadcrumbs. Below that, the master view, high-level summary charts and KPI cards. And to the right or below, the detail view, deeper breakdowns and data tables. A simple grid structure helps enormously. Aligned elements look intentional, misaligned elements look careless, and erode the reader's confidence in the data itself. Stephen Few, one of the leading authorities on dashboard design, identified a set of pervasive pitfalls that undermine even well-intentioned dashboards. Let's go through them. There are 8. The first is exceeding a single screen. A dashboard that requires scrolling has violated its core purpose. Everything essential must be visible immediately. If you have too much content, the solution is not a longer page. It is better prioritization or additional pages. The second is providing inadequate context. A number without a benchmark, target, or historical comparison has no meaning. $4 million in revenue could be a triumph or a disaster, depending on context. The third is displaying excessive detail or precision. A dashboard is not a report. Showing 6 decimal places on a KPI card or displaying individual transaction records overwhelms the reader. The fourth is choosing inappropriate display media. The most common example being the gauge chart. A gauge conveys a single value using a large amount of space and forces the reader to decode an angle rather than read a number. A KPI card with a variance indicator is almost always superior. The fifth is poor data management. No visual hierarchy, no consistent reading order, elements placed without regard for the optical area. Principles we have already discussed. The sixth is color misuse. Too many hues, inconsistent color encoding, or using color for decoration rather than meaning. The seventh is cluttering the screen with useless decoration. Logos, gradients, borders, and shadows. These add visual complexity without adding information. And the eighth, is ineffective highlighting. When everything on the dashboard is bold, colored, or emphasized, nothing is. Highlighting only works when it is used sparingly. We have covered what to avoid. Now let's consider the positive action items. The steps to take before and during dashboard design to maximize the likelihood of success. Before you open Power BI or any other tool, you should complete 4 preparatory steps. First, define the data type you are working with. It can be nominal, ordinal, or metric, as this determines which visualizations are appropriate. Consider how frequently the data will be updated and ensure the dashboard design reflects that frequency. Understand your users thoroughly, their role, their technical comfort level, what decisions they make, and how frequently they will use the dashboard. And evaluate whether the BI platform you have selected can actually deliver what you need. Once you begin designing, 6 further principles apply. Define clearly what the dashboard is trying to achieve. Prioritize substance over style. Stay focused on user needs rather than your own aesthetic preferences. Keep only the metrics that are truly necessary. Ensure every metric satisfies the 4 criteria we discussed: actionable, transparent, accessible, recognizable, and ensure metrics support meaningful comparison. Rather's 8 best practices listed here on the right extend these principles further. Particularly noteworthy are the concepts of wrapping metrics with contextual metadata, that is, providing the benchmark alongside every number, and presenting information in 3 levels of detail: summary for at a glance reading, context for understanding, and detail for investigation. Now we bring together what we have discussed so far in a direct visual comparison. On the left, you can see a well-designed dashboard. On the right, you see one that deliberately violates the principles we have covered. I want you to examine both carefully because recognizing the difference in practice is as important as knowing the theory. The good dashboard on the left opens with a clear title that includes the reporting period and scope. Month ending May 2024, region all. There are 4 KPI cards at the top, each showing the current value and the variance against the prior month. Color coded appropriately. Green for improvement, red for decline. Below that, a line chart compares actual revenue against target over 5 months, with the gap between the two visually filled to draw the eye. A bar chart on the right shows regional revenue sorted from highest to lowest, with the leading region highlighted. At the bottom, a simple pie chart shows customer segment composition alongside a clean data table. Every visual answers exactly one question, and the layout follows the optical area principle. Most important information at top left. The bad dashboard on the right violates almost every principle we have discussed. The title is decorative and contains no date or scope information. A 12-slice pie chart attempts to show all 12 months of revenue. This is fundamentally the wrong chart type for time series data as well. And 12 slices are far too many for a pie chart. The bar chart uses a truncated y-axis that starts at 95.5, making a difference of less than 2% appear enormous. A line chart attempts to show 15 product series simultaneously using rainbow colors. It is completely unreadable. A gauge chart wastes a large area of screen space to show a single number. And a raw data table displays 10 columns of transaction level data with 6 decimal places of precision. The contrast between these two examples is not subtle. Good dashboard design requires conscious effort and deliberate application of principles. It does not happen by accident. Now, after learning the conceptual framework, let's briefly orient ourselves in Power BI, which is the tool we use to apply these principles in our practical sessions. Power BI is structured around 6 core concepts. The first is get data. Power BI can connect to over 100 data sources, including Excel files, SQL databases, REST APIs, SharePoint lists, and cloud services. This is where the data journey begins. The second is Power Query. This is Power BI's data transformation layer. Before any data reaches a visualization, Power Query allows you to clean it, reshape it, filter it, and combine it from multiple sources. Think of it as the extract, transform, and load step that feeds the model. The third is the data model. Once your data is loaded, you define the relationships between tables. For example, linking a sales fact table to a product dimension table and date dimension. The model is the structural backbone of everything else. The fourth is DAX measures. Data analysis expressions is Power BI's formula language for custom calculations. With DAX, you can build metrics that go far beyond simple sums. Year-over-year comparisons, running totals, ratios, and conditional aggregations. The fifth is visuals. Power BI provides over 30 built-in chart types and hundreds more are available through the AppSource marketplace. The chart selection principles from earlier in this lesson apply directly here. And the sixth is bookmarks and filters. These are the mechanisms through which you create interactive drill-down experiences for your users, allowing them to explore data at their own pace without writing any code. Let's finish the lecture with a summary of the 6 key takeaways from this lesson. First, data visualization transforms raw data into insight. What you display should always be information, aggregated, contextualized, and meaningful, not raw records. Second, choose charts purposefully. The choice of chart type is determined by the data types involved and the analytical question being asked. A mismatch between chart type and data type always reduces clarity. Third, color and storytelling are not optional extras. Color encodes meaning, and every visualization should guide the viewer through a narrative that ends in a clear insight or action. Fourth, dashboards are consolidate. Their value lies not in individual chart, but in the integrated interactive view they provide across multiple metrics and data sources. Fifth, metrics must be actionable. Every metric on a dashboard should connect to a decision or action and should allow meaningful comparison over time across categories or against targets. And sixth, design intentionally. Apply the layout principles, observe the optical area hierarchy, and systematically avoid the common pitfalls. Good dashboard design requires discipline, not just creativity.